So this is going to be a more focused lesson. I'm specifically going to be talking about factoring out the greatest common factor, which is something that you need to be able to do for problem 1 on the assignment for this week. So problem 1 on the assignment, you have to first factor out the greatest common factor, and then you factor what's left. I have another video for how to factor trinomials, and that's what you would have to do for your second step. But the first step is to factor out the greatest common factor. So that's what we are going to be doing today to show you how to do that. So a factor is a number or quantity that, when multiplied with another, produces a given number or expression. That is a very confusing definition, but basically, like if I have two numbers, if I just multiply like 3 times 4, 3 times 4 gives me 12. Those numbers that we can multiply to get 12 are considered factors of 12. So 3 and 4 are factors of 12. Basically, a factor of a number means that it can divide evenly into that number. If you divide it, you're not going to get any decimals or fractions. So that's what a factor is. So the greatest common factor, first, greatest means that it's going to be the biggest number, and common means it's going to be in common. So it's basically the biggest number that is in common. If you have a set of numbers, it's the largest one you can divide out of all of them. And we usually find the greatest common factor by doing prime factorization, which is something that I've done in like my fraction videos. And then when we were looking for the common denominator, we did some prime factorization with that. So I think this is going to be a lot easier if we just look at specific numbers and examples so you can see how this works. So we're going to just start with the greatest common factor, and we've got two numbers, 30 and 42. So the greatest common factor is the largest number that divides into 30 and 42. So I'm going to write that down so you have that and you know exactly what you're looking for. So, and we abbreviate greatest common factor as GCF. So the GCF is the largest number that divides evenly, which means no decimals or fractions, into both 30 and 42. So if you know your times tables, or you're really good at, your division and everything like that, you can actually figure this out. So if we do this mentally, you just ask yourself, what is the largest number I can divide into 30? And what is the largest number that I can divide into 42? So if you're just thinking about your times tables, that would be, or like the first one that comes to my mind is 6. 6 goes into 30 and 6 goes into 42. So I'm going to just write that down. 6 goes into 30 and 42. So mentally, that would be my guess for the greatest common factor, that's the largest number that divides into both 30 and 42. But we can also do this with a factor tree, or prime factorization. So that's what I'm going to do in purple. So I'm going to take both numbers, 30 and 42, and I'm going to make factor trees. So 30, I can split that up as like 6 times 5. And then 5 is a prime number, so I'm going to circle that. And 6 can split up as 2 times 3. And 2 and 3 are both prime numbers, so I'm going to circle those. 42, I know, is 6 times 7. 7 is a prime number. and then 6 is 2 times 3, and those are both prime numbers. So when you're looking at the greatest common factor and you have a factor tree, you want to look for what's in common. So I'm going to highlight what they have in common. So they both have a 2. They both have a 3. And then that's the only thing they have in common. The 30 also has 5, 42 has a 7, but those are not the same. So the only thing they have in common is 2 and 3. And so what you do is you multiply those together, which is 6, and that is your greatest common factor. So in common, they had 2 and 3 in their factor trees, and then you multiply those, and that gives you the greatest common factor, which is 6, which is the same number I got mentally by thinking about what numbers can I divide into 30 and 42. What is the biggest one that I can think of that goes into both of these numbers? So are there any questions on that example? I know, Phyllis, you joined us a little bit late, so you missed the first part, but hopefully you were able to follow the prime factorization part. Okay, so I'm going to assume that there's no questions there. I'm going to look at another example here. This time we're going to look at 3 numbers, but it's basically the same thing. So you are looking for the greatest common factor, which is the largest number you can divide into 28, 63, and 7. So the GCF is the largest number that divides into 28, 63, and 7. So whenever I have a set of numbers and one of the numbers is prime, 7 is prime, I ask myself, does that number itself go into the other 2? So this is prime, so only 1 and 7 divide into it. So 7 divided by 1 comes out to a whole number, and 7 divided by 7 comes out to a whole number. So I ask myself, okay, so that means if I'm looking for a greatest common factor between all 3 of these, I want to look at, my only choices are 1 and 7 to go into 28 and 63. That's the only possible choices because there's only 2 choices that I can divide into 7. So we want the largest one, so you're going to ask, does 7 go into 28 and does 7 go into 63? So I'm going to write this in a different color just so I can, so that is the largest. And that color is going to not, let's see, there we go. So does 7 divide into 28 and 63? So, well, 28 divided by 7, that gives me 4, so that's a whole number. And 63 divided by 7 is 9, which is a whole number. So that means, yes, 7 divides into 28 and 63 because they come out to whole numbers. So 7 divides into 28 and 63. So that means 7 is our greatest common factor because it's the largest thing that divides into 7 and it goes into both 28 and 63. So this is just another way of thinking about the greatest common factor and thinking about it mentally, thinking about it as a little puzzle. Is take your smallest number and think about what can I divide into there, and then see if those divide into the other numbers. Especially if you have a prime number, because that limits your choices on what can go into it. Are there any questions on this? Okay. So moving on to variables, because when we were factoring for the assignment this week, we involve variables. And finding the greatest common factor when you have variables is actually easier than when you're doing it with numbers. Believe me. When you are finding the greatest common factor and you have variables, you are looking for the smallest exponent, and that is automatically your greatest common factor. So the sort of teal color here, if you have x to the third and x to the fifth, the smallest exponent is 3, so the greatest common factor is x to the third, because that has the smallest exponent. If you have something with what is called a binomial expression, which means you have something in parentheses, then you still look at the smallest exponent. So that's the example in blue, where we have x plus 3 and then x plus 3 squared. So the x plus 3 doesn't have an exponent, so that would be smaller than something that's x plus 3 squared. So our greatest common factor is x plus 3. They basically both have an x plus 3 in there. So that's your greatest common factor. So it's actually easier than when we have numbers. So let me move on to an example to kind of demonstrate this. So 2 examples. The first example on the left doesn't require a lot of space. We have 3xy and 7y. I don't know why I read that as 37. 3xy and 7y. So first you look at the greatest common factor between the numbers. So is there a number I can divide out of 3 and 7 and get a whole number? 3 and 7 don't have anything in common. They're both primes, so I can't divide the same number from both of those. So then you go to the variables. I have an x in 3xy, but there is not an x in 7y. So we need to be able to divide it out. I can't divide an x out of something that does not have x. So I can't divide x out of 7y. So there's not going to be an x with my greatest common factor, because there's just, it needs to be in both things. Then we look at the letter y. We have a 3xy and a 7y. They both have y in common. So just like how I was looking at the factor tree, you're looking at, well, what do they have in common? They both have a y in common. So that would be my greatest common factor, because they didn't have a number that I could divide out, and I couldn't divide out an x, but they both have y. So my greatest common factor is y, because that's the only thing they have in common that I can remove, that I can divide out. Now let's look at the second example here. We have 12w cubed z and 16w squared z. So we're going to work piece by piece. We're going to find the GCF out of the numbers, the GCF out of the w parts, and then the GCF out of the z parts. So we want to first find the GCF of 12 and 16. So we want to ask ourselves, what is the biggest number I can divide out of 12 and I can divide out of 16? So I'm going to ask you guys this, and you can type it in the chat box. What is the largest number that you can divide out of 12 and 16? And Christine, you say 4. That is correct. 4 divides into both of those. So our GCF here is 4. Next, we're going to find the GCF out of the W. So we have W cubed and W squared. So when you're comparing those variable parts, you have to have the same letter, and then you're looking at which has the smallest exponent. So the smallest exponent is 2, so W squared is going to be our greatest common factor. Yes. Go ahead. Phyllis, you can either turn on your microphone and ask it, or you can type it in the chat box.
So you saying that the greatest common factor of W3 and W2 would be 2?
Yes,
the smallest
W2.
numbers?
Yeah, so you pick the one with the smallest number and you keep the variable. So you're basically choosing from out of those two which one is smaller.
That'll go into that number.
Yeah.
Okay.
Yeah, so it's separate from the number parts. It's like numbers is different really from the letter parts, and you go line by line. So if we move on, the next letter that we have is Z. So we are looking for the GCF. We have Z in the first one, and then we also have a Z in the second thing there. Z and Z, those are exactly the same. So that's going to be your GCF. You can divide a Z. You can remove a Z from both of those because they both contain a Z. So you put all of these things together. You find the GCF of the number portion, then each letter portion, and then that is your actual GCF out of the whole thing. So let me write this in a kind of different color here. So the GCF of 12W cubed Z and 16W squared Z is 4W squared Z. So you work piece by piece, and then you combine those together, and that gives you your greatest common factor. Are there any questions? Okay. Now we're going to do another one. This is a little more complicated because the number is bigger. There's more variables. So we have 15 r squared s squared t to the 5th and 325 r cubed s to the 4th t cubed. So we're going to work piece by piece. We're going to first look at the numbers, then we're going to look at the letter R, then we're going to look at the letter S, and then the letter T, and you keep going until you've gone through all the different variables. So first, we want to find the GCF of 15 and 325. Now, 325 is a large number, and I, off the top of my head, don't know my times tables for 325, so I don't know what the largest number is that goes into that. So when I have a large number like that, then that is where I go to the factor tree. So I'm going to first make a factor tree for 15. So I know that 15 is 3 times 5. And those are both prime numbers, so I'm going to be circling those. And now I'm going to make a factor tree of 325. And I'm going to need my calculator for this because off the top of my head, I don't really know what two numbers multiply to 325. But I do know that because 325, the last digit is a 5, I know I can divide it by 5. So I'm going to do 325 divided by 5 on my calculator, and that comes out to 65. So 5 is a prime number. I'm going to circle that. Now 65, I know I can divide 5 out of that because the last number is 5. So I'm going to split that up, and 5 is prime. And then I'm going to do 65 divided by 5 on my calculator, and that comes out to 13. And 13 is a prime number. There's nothing that divides into it other than 1 or 13. So now that I've made my factor tree, I want to highlight what they both have in common. So I have a 5 and a 5. But that's the only thing they have in common because I have to match them up. So while there is another 5 in 325, I don't have a 5 on the 15 part to match it up with because you have to do it in pairs. So the only thing that they have in common is 5. So that means the GCF out of 15 and 325 is 5. That's the only thing they have in common. So if I was trying to do this by like trying to figure out what numbers divide into it, I'd probably be guessing and trying to say, well, is there anything bigger that goes into 325? But by doing the prime factorization, I know that there isn't anything bigger because I can just, highlight and match them up, and then I see, okay, that's the only thing that goes into both. So once you've looked at the numbers, next you have to move on to the letters. So the next letter is R. So we are looking at the GCF, and in the first set we have, or the first term, we have 15R squared S squared T to the 5th. So we have an R squared. And then in the second term, we have an R cubed. So when you're finding the greatest common factor, you look for which one has a smaller variable or the smaller exponent, which is R squared. And that is your GCF. So you want the one with the smallest exponent. Now I'm going to move on to the next letter that I have, which is S. So in my first term, I have an S squared. In the second term, I have S to the 4th. So you want the smallest exponent. So 2 is smaller than 4. So that means S squared is my GCF for that portion. The next letter we have is T. So I want the GCF of, I have T to the 5th in the first term and T to the 3rd in the second term. So the smallest exponent out of 3 and 5 is 3. 3 is smaller than 5. So that is our GCF. So that is T to the 3rd power. So you want to stick all of these things together to get your final answer. So our GCF, greatest common factor of 15R squared S squared T to the 5th and 325 R cubed S to the 4th T to the 3rd is, let's write is, and I start with the number, so that was 5. Then I have R squared S squared T to the 3rd. So I'm just taking my 5, my R squared, my S squared, my T to the 3rd, and you just combine them all together, and that is your greatest common factor. Are there any questions? Okay. So next is the actual factoring part. So first you have to figure out the GCF before you do the factoring part. And when we say we are factoring, that means we are reversing the distributive property. So when we distribute, we're multiplying through the parentheses. Factoring means trying to figure out what you multiplied and pulling it back out. So you're undoing what you did last week. It's like the reverse operation. And there are two different methods that you use. So we have method one. Whoops, I forgot I was on highlighter. Method one is what the book does. And then method two is my preferred method. So I'm just going to call this Stephanie's method. So there are two different methods, and I'm going to show you both methods, but I have the steps for them both here. So what the book does, and they both start with the same step, is you have to figure out what the greatest common factor is. Then for method one, after you've figured out the greatest common factor, you are rewriting each term so that you have the greatest common factor times something else. So it says rewrite each term as the product, and product means multiplication. So you're multiplying your GCF times something else. Then you are using the distributive property in reverse to remove the greatest common factor. My method starts the same. You're identifying what the greatest common factor is, but then I'm having you rewrite what you have, where you put your greatest common factor in front, you add parentheses, and then you take each of your terms and you create a fraction with the greatest common factor. Then what you do is you're simplifying those fractions inside the parentheses by using the rules of exponents, where you're dividing the numbers, and then those rules of exponents we learned last week is if you have a fraction, you subtract the exponents. So that's my method. I'm going to show you both of these methods on the same problem so you can see how they work side by side. So we want to factor out the greatest common factor from 3q minus 15. So we're looking for first, we want to find the greatest common factor of 3q and 15. So you don't worry about the minus part in there. You're just looking for the greatest common factor of each term. So we have 3q and then we have that 15. So we look at each numbers and we want to first find the greatest common factor out of 3 and 15. So the greatest common factor of 3 and 15. And that one you can do mentally. You can say, okay, what number can I divide into 3 and divide into 15? And that's 3. Then you have the greatest common factor of you have something with q and you have nothing there. There's nothing there. So you don't have anything. There is no greatest common factor there. I don't know if the boxes might be more confusing. But that just means you don't have anything to compare it to. You can't remove a q because it's not in the 15. So since it's not in both, we can't make it part of our greatest common factor. So the only thing that they have in common is 3 that you can divide out. So step 1 was identifying the greatest common factor. So the greatest common factor is 3. So that's the same step for both methods. Now method 1, what they do is they are rewriting what they have as that greatest common factor times something else. So let's see, step 2. It's gonna involve multiple steps. So first we have 3q minus 15. Our greatest common factor is 3. So we're going to separate 3 out from what else is there. So we're going to just put these in parentheses. So I have a 3, And to get to 3q, that means I just need to separate out that q. And then I look at the 15. I'm going to have a 3, and then I say, okay, 3 times what gets you 15? So 3 times 5 is 15. So I have to put a 5 in my like little missing area there. So this, I don't like this method because it gets a little confusing. You figure out your GCF, and then you are kind of separating it out and figuring out what you'd have to multiply by to get back to where you started. So if you worked backwards, 3 times q gives you 3q, 3 times 5 gets you 15. Then step 3 in method 1 is to reverse the distributive property. So that 3 ends up in front, and then what you multiplied it by is inside the parentheses. So because if you distribute it, you do 3 times q, and that gives you the 3q going up, and then 3 times 5. So it's like you're working backwards. So your answer is this 3 in front times q minus 5. So you can always check your answer by multiplying it back out, and you'll get back to 3q minus 5. Like if you work down and move up instead of up down, you know, if you're kind of working in reverse. So that's method 1. I find that method a little confusing. So that's why I don't use that method, and I have my own method. So method 2 is my method. First step is the same. You need to find your greatest common factor. Step 2 is you write your greatest common factor in front. You create parentheses. Actually, let me start with what we have. We have 3q minus 15. I'll start with it. That's what we have. Then you put your 3 in front, and then you take each term, 3q, and you write it over your greatest common factor. And then I just put the minus sign in front, and then I have my 15, and I write it over the greatest common factor. So you take your GCF, you put it in front, and then you're creating fractions with what you had before, the 3q minus 15. So we're creating something that looks slightly more complicated, but it's actually easier. Step 3 is to actually simplify that. So I have a 3 in front, and then I need to divide. So I have 3q over 3. The 3's cancel out because 3 divided by 3 is 1. So those cancel, and I'm left with just a q. And then I have my minus sign, and then I do 15 over 3, which is the same as 15 divided by 3. So 15 divided by 3 is 5. So then I have that 5 there. And so I get the same answer. We're just writing it differently than in method 1. And so it sort of depends on which way your brain works, on which method you prefer. So I'm curious, for those of you guys who are currently live with me, which method do you prefer? Do you prefer method 1 or method 2? And maybe tell me why, so you can like type that in the chat box. Or you can say it out loud. If you can turn on your mic and say it out loud too. Okay, Christine says method 2 seems simple, but I get both methods. Well, that's awesome if you understand both methods. I have a hard time with method 1, and even though I know how it works, if I have something that's more complicated, I struggle with that. Do we have any other opinions on which one you prefer, method 1 or method 2? Phyllis or Lloyd?
I
Yeah,
think
Phyllis.
method 2 is a little easier because you dividing 3 into 15, but you get your
Mm-hmm.
answer right away.
Yes, yeah, I agree. I definitely think because you can see the division right there, you're not, I feel like it's less thinking, you know? So I'm going to move on. I'm going to go forward with method 2 for these examples, just since that seems to be, it's my preferred method. I think it's easier. I think is less prone to mistakes. So that's what I'm going to be using going forward. But I just want you guys to know that the book shows method 1. So if you see what the book does, that's what it's doing. Don't freak out that it's different from what we're doing. And this one actually, yeah, you know, like I'll do both. I'll do method 1 here. I forgot that I was going to do another one to show you both. I'll show you method 1 on this example, then method 2 for this one, because this one's even more complicated. And then from then I'll do method 2. So we'll do both methods here just to demonstrate. So I have 16d cubed plus 24d squared plus 32d. So we want to find the greatest common factor of, we're looking at our 16d cubed, 24d squared, and 32d. So we're looking at 3 of these things. And so we want to first look at the numbers. We want the GCF of 16, 24, and 32. So you want the biggest number you can divide into all 3 of those. So 8 divides into 16, 24, 32. That is the largest, and that's just because I know my times tables. So 8's the biggest number that goes into those. And then you look at the variables. We have the GCF of d cubed, d squared, and d. So you want the smallest exponent, and the thing with the smallest exponent would have no exponent, so that's just the d, because that's having nothing written there is smaller than having a 2 and a 3. So step 1 for using method 1 is to find the GCF, and our GCF is equal to 8d. So step 2 of method 1 is you want to take what we have 16d cubed plus 24d squared plus 32d, and we want to rewrite all of these so that it's 8d times something. So I'm going to just leave blanks here so that you can see that we want to rewrite these so that there's the 8d, but then there's something else. So I look at my 16d cubed. So I have an 8. 8 times what gets me 16? So 8 times, I'm actually going to do this in slightly different color there. So 8 times 2 gets me 16. So I have to fill it in with a 2. And then I have a d, and I need to get a d cubed because I'm kind of splitting it up. I'm kind of working backwards. So if I have a d, I need 2 more d's to add up to 3 of them, to have 3. So that's going to be a d squared. Then I move on to my 24d squared. So I'm splitting up, so I have 8d. So 8 times what gives me 24? So 8 times 3 is 24. And then I have a d. I need to get a d squared, so that's 2d. So I need to add a second d there so that those give me a d squared. Then I have my 32d. So I have to have 8 times what gets me 32. So that's 4. And then I have a d, so I don't have to add on any extra d's there because I already have a d. I don't need any more. So that's step 2, is to kind of split that up and then fill in the blanks. And my S doesn't want to write, apparently. So step 3 is then to pull those out in front. So we have 8D, that was our GCF. And then everything I have in blue gets written inside parentheses. So I have 2D squared plus 3D plus 4. And you put plus signs in front because they had plus signs to begin with. So I'm going to just highlight everywhere I have this GCF so that you can just kind of see how that works, that you basically put it in front and then everything else goes in parentheses. So that's method 1. The hardest part is step 2, where you're trying to figure out what I have in blue. You're figuring out those parenthesis parts and figuring out what do I have to write there. That's the hardest part, I think, to do in your head. So I'm going to do the same thing, same exact problem. We're going to use method 2, which is my method. So we already know the GCF because we found that on the first. So we know that step 1, we know our GCF is 8D because we already figured that out on the previous slide. So then step 2. So I'm going to start with rewriting what I have. 16D cubed plus 24D squared plus 32D. Then the next step is to write my GCF in front and then put everything that I have as a fraction over my GCF. So I have 16D cubed over 8D plus 24D squared over 8D plus 32D over 8D. So I have that GCF, I put it in front, and then I write it on the bottom of all these fractions I created, basically. Then step 3 is to simplify. So I have my 8D, and then you start doing division. So I have 16 divided by 8, which is 2. And then this is where the rules of exponents come in, because if you have a d cubed over a d, that d has an exponent of 1, and you subtract the exponents. It's top minus bottom. So you would have 3 minus 1, so that would be squared, because that's a 2. Then I move on to the middle. I have 24 divided by 8, which is 3. And then again, that d would have an exponent of 1, and you subtract it, because you're removing a d. So you have 2, you've removed 1. 2 minus 1 is 1, so that's a d. And then we have 32 divided by 8, which is 4. And then those d's just cancel out. So you don't have to write anything there. And then that's your final answer. That's the same exact answer that we got using method 1. We're just writing it differently. Do you guys still prefer method 2 over method 1 after seeing a little more complicated example here? Okay, so Christine, you say now method 1 is easier to dice the problem up in order to solve it. So that's interesting. So now that you've seen a second example, now you prefer method 1. So it's a good thing we're showing both methods, because it depends, whether you like this method or maybe if you like this method 1, where you're just kind of filling in the blanks and then pulling it out in front. So it's really up to you which method you do. I'm going to just continue doing method 2 because that's the method I prefer, but you are welcome to do these with method 1 if that works for you. I'm not going to stop anybody. That's not wrong. And actually, there are some cases, like when we do factoring by grouping, that I'm essentially doing method 1. So there are times where that is a good method. Okay, so next example here we have negative 9y to the 5th plus 3y cubed minus 12y. So I'm going to use method 2 here. So I'm going to just write that using method 2, just so that you have that note when you know that that's what I'm going to do. So first thing is to find the GCF of these, each term. Now the one thing, there's something special about having a negative in the front. If your first term is negative, your GCF is negative. So that's just a rule that we have. And we do that because it makes it easier to factor by grouping down the road. So if you have a negative in the very front, then your GCF is going to be negative. So we want to find our GCF of, we have negative 9y to the 5th, 3y to the 3rd, and negative 12y. So I actually don't even really need to have the negative with that 12y because we can treat that as a minus, so we can just say 12y. But that negative in the front, that's really important. So first, we want the GCF out of the numbers. So we have negative 9, 3, and 12. So because that first term is negative, our GCF is going to be negative. And then we're looking for the biggest number I can divide out of basically 9, 3, and 12. And that's 3. I can divide a 3 out of 9, 3 out of 3, and 3 out of 12. So out of those numbers, 3 is the biggest thing I could divide. And then you're looking at your variables. We have y to the 5th, y to the 3rd, and y. So having no exponent at all means it's smaller, so our GCF is going to be a y. So step 1, the GCF is equal to negative 3y. So I have to have that negative because my very first term is negative. Step 2. So first I'm going to write what we have. Negative 9y to the 5th plus 3y to the 3rd minus 12y. And now I'm going to write my GCF in front. Negative 3y and then parentheses. Then negative 9y to the 5th over negative 3y plus 3y cubed over negative 3y. And now when you have a minus sign here, it's always best to put a plus and then put the minus on top when you have your fraction. So that's going to be a minus 12y over negative 3y. And that just helps, especially when you're dividing by a negative, so that you don't make any mistakes with your negatives, because I know it's really easy to miss a negative somewhere. So then step 3 is to simplify this. So you have your negative 3y in front, and then you divide the things that are in the parentheses. So I have a negative 9 that I need to divide by negative 3. So a negative divided by negative is a positive. So 9 divided by 3 is 3. So I have a positive 3. And then you are subtracting your exponents. So you're basically, anything that doesn't have an exponent can have an exponent of 1. So 5 minus 1 means I have 4. So I'm going to have y to the 4th. Now I have a 3 divided by a negative 3. So that's going to give me a negative 1. And then I have a y. And then when I subtract the exponents, 3 minus 1 is 2. So I get a y squared. then -3 divided, or -12 divided by -3. That gives us a +4, and then the y's cancel. 1 minus 1 is 0. So there we have factored out the greatest common factor. Are there any questions on this example? Any questions on anything I did? Okay. Well, I have one more example for you, and this one is basically method 1 that we're doing here, and this is something that when we have a binomial factor. So the binomial factors are when you have things in parentheses that match. So these are binomial factors. And this is something you get when you do factoring by grouping. So if you have things in parentheses like that, you can think of that is your GCF essentially, because it's the same thing. It kind of goes back to that method 1. So we'll be using method 1 here because it's already in that form. It's already separated out as something times something else. So step 1 is to identify the greatest common factor. And so the only thing they have in common is an x squared plus 1. That's the only thing that's in common between them. Otherwise, there's a 7 and a y. They don't have anything that matches. Step 2, you would rewrite it, but it's already written out for us so that it's separated out. And it doesn't matter whether you have the GCF in the front or the back. It's just a matter that you have that GCF and it's separated out. So step 3, you always put your GCF in the front, and we have to make sure we have parentheses around it because that's the entire GCF. And then in your set of parentheses, you have what's left over. So we have a 7 in front and then a minus y. So we have if I keep highlighting all our GCFs here, so I've got that x squared plus 1. So I basically pulled it out in front, and then what I was left over that I removed, or that, I removed the x squared plus 1, and what was left over ends up in the set of parentheses in the back. So you end up having 7 minus y. So I'm going to just quickly flip over to let's see, example 5. So you can see how it's the same sort of thing. You have your GCF, you separate your GCF out, and then that goes in front, and then what's left over gets into a set of parentheses here. So that's why I kind of color coded and had the highlighting, so you can kind of see how those work. And I'm also going to, look at method 1 here in example 4. You had the 3 in common, you put it in front, and then what was left over kind of gets into a second set of parentheses. So going back, even though our GCF is in the back, it still works the same. You put it in front, and then in parentheses after it, you put what's left over. And this is basically a few steps into factoring by grouping. If you factor by grouping, you have to do a few more steps, and then you'll get to this. Are there any questions?
No, there's not. It's not. It's fake.
Phyllis or Christine, do you guys have any questions?
I'm keeping
Yes,
up.
Phyllis.
I'm with you.
You're with me. Good. Let's see, I'm trying to remember if I actually logged into, I'm actually going to show you guys, I'm going to just bring up our course to show you some other videos just to make sure that, you know where the other videos that are that can help in case you need more practice. So we are in week 5. So if you need more practice on just doing the greatest common factor, there's this first video. So I go into that with much more detail. So if you need more practice there, this video will help. This one is basically what I've just done, so I'm going to replace it. It's updated. Then the next step, once you factor out the greatest common factor, is to factor trinomials. So for the assignments, the problem 1, you have to first factor out the greatest common factor like we just did. Then you have to factor further. So that would be factoring trinomials. So for problem 1, you're going to want to watch this video after you do the greatest common factor. For problem 2, I actually recommend that you do the AC method. So you might want to watch this one because problem 2 doesn't have something that you can factor. If I'm remembering correctly, there's no greatest common factor, so you have to do this. So I would make sure you watch this video as well. And then there's some shortcuts to factoring, and that's this last video. But definitely I would watch this one if you need extra on the greatest common factor, and then make sure you're watching these 2 videos because those will go into more details than what you need for the assignment. Do you guys have any questions? Anything else for me? It looks like someone's typing. Maybe. Oh, Samuel says assignment 2 also has the greatest common factor. Thank you. I could not remember that, whether that did or not. Actually, I can open it up and take a look at it just to make sure. Ah, yes, there is also a greatest common factor in assignment 2, but from there you're going to want to use the AC method. So for problem 1, because you have that negative in front, your greatest common factor is going to have to be negative, but you'll have a positive greatest common factor for problem 2. So hopefully that will, oh, I forgot that I'm not sharing my screen. I forgot that I turned that off, so I'm pointing to something that you guys can't see. Okay, so problem 1, because it has that negative in the front, your GCF has to be negative. And then problem 2, you're going to have a GCF. For both of these, your greatest common factor is only going to be a number. You're not going to have any variables in your GCF. So that's going to make it easier because all you need to do then is divide out a number. And then from there, you need to basically do the factoring trinomials. So hopefully this gives you enough information for you guys to go forward on the assignment. Definitely check out those videos. Those should help a lot. I've heard people say that if they watch the videos before read the textbook, it helps them. So that could be if you haven't tried that before. So thank you guys. If you guys don't have any other questions for me, thank you so much for attending. I really appreciate it. And of course, if you guys come up with questions later down the road, as you're working through the assignments, feel free to let me know, send me an email, send me a message to remind, or maybe a picture of your work. I can take a look and see maybe if you have any mistakes or something like that. So you're welcome to do that. So Sam said you have headaches figuring number 1 out. You know, let me actually download the template. And I'll kind of get you guys started on that one. I would have to switch my screen sharing to my other screen. Hold on a bit. I'm going to move you guys to another screen. I have too many screens here. Okay, so for problem 1, we'll just do what we just did here. So first, we need to find the GCF. And we're looking for negative 5c squared. And you can keep the negatives. It really doesn't matter whether you keep the negatives or not when you're doing this. The key is the numbers and the fact that our GCF here is going to have a negative. So when I look at the greatest common factor out of the numbers, let's just look at 5, 45, and 70. So 5 only goes into 5. So the question is, does 5 go into 45 and does 5 go into 70? So 5 does divide into 45 and it divides into 70. So our greatest common factor here is 5. And then when you look at the variable parts, you would have c squared c, and then you have a blank. If c is not present in anything, you can't factor out anything. So there's just nothing that you can factor out here. So your only GCF is going to be 5, and because we have a negative in front, we're going to factor out a negative 5. So I'll do this with method 1 just for a change, since I did the others with method 2. So with method 1, so we have our GCF, which is negative 5. So I'm going to just rewrite these, and we want to rewrite each of these so that you have a negative 5 in front, and then you have to fill in the blanks. So my negative 5c squared, so I have a negative 5, so I need to fill in the blanket for c squared so that I can match it up with my negative 5c squared. The middle, I have negative 45c, so I have a negative 5, and I have to figure out how to get to negative 45. So a negative 5 times a positive will get me negative, and 5 times 9 is 45. So I have a 9, but that only gets me negative 45. I need negative 45c, so I have a c there as well. Then in the end, I have negative 5, and I need to know negative 5 times what gets me 70. Well, I don't know that, so I work backwards and divide. So I would be doing negative 5 times, or 70 divided by 5 to figure out what the number is. So that gave me 14. So that means that a negative 5 times 14 will get me a negative 7. So for method 1, that's how you're splitting up your greatest common factors, and then you put that in front, and then everything that I was filling in the blanks for gets in parentheses. C squared plus 9c plus 14. But you're not done here, because that's just factoring out the greatest common factor. This in parentheses we need to factor. So here you need to factor a trinomial. So I do have a video on that. So see my video on factoring trinomials. So you'll want to watch that video to fill that in, and your final answer will have negative 5, and then you'll have 2 sets of parentheses with things inside there that you will have to fill in yourself. But that will at least get you started based off of what we talked about today. As you find that GCF and factor it out, and once you're there, you need to then factor the trinomial. So I recommend watching my other video for that. Does that help, Samuel? Hopefully it does. I don't know if you... Yeah,
It helped
Phyllis.
me.
Oh, good. Well, as long as it helped someone. I'm not getting a message back from Samuel, so hopefully it helped him. I think he's been having connection problems, but as long as it helps someone, I am happy for that. So for the second problem, you would do something similar. You would have a different GCF, but it would be a number. Oh, and Samuel says it would have been helpful 3 hours ago. I'm sorry. Lesson learned, if I'm going to be doing a live session, hold off on homework until you watch the live session. That could save you some grief. Anything else? I don't want to do the whole homework assignment for you guys, because then you're not learning anything there. But at least I got you started and you have an idea of what you need to do. Okay, Samuel says you're typing stuff. Oh, okay. There must be some delay or something there. All right. Well, I have kept you guys for over an hour now, so I don't want to steal all of your time. I'm sure you guys have stuff to do before work tomorrow and all that good stuff. So I'm gonna let you go here. I'm gonna make sure that I get this video out tomorrow morning, so that way if you need to watch it a second time, you can. You can watch those other videos in the classroom, and those should be helpful as well for everything you need to do. So that is it. Thank you guys again so much for attending and asking questions. I really appreciate it. And I will let you know when my next one is going to be. You will get an email about that tomorrow, because I'm going to try to figure it out tomorrow so that way you can plan ahead. So, all right, thank you again, and I will see you guys at the next